Hello children, welcome to Deepika Tutorials. This is your Deepika ma'am. In today's class we are going to start class 10 mathematics. It consists of two parts, part 1 and part 2. In part 1 consists of 7 lessons. So first lesson is real numbers, second lesson is polynomials, third one is pair of linear equations in two variables, fourth chapter is quadratic equations, fifth chapter is arithmetic progression, sixth chapter is triangles, seventh one is and coordinate geometry. In the part 2 starts from 8th lesson, introduction to trigonometry. 9th chapter is some applications of trigonometry. 10th one is circles, 11th one is areas related to circles, 12th surface areas and volumes, 13th one statistics, 14th one probability. So you have total 14 lessons. Okay, in that 14 lessons, from today onwards we are going to start our first lesson. So your first lesson is about real numbers. So before going to start the lesson, I would like to recall all the basics needed for this lesson. So children, can you tell me what are real numbers? Yes, see, in the number system, if you take number system, we mainly divide the number system into two subcategories. One is real numbers, the second one is imaginary numbers. Okay, so in these numbers again we are going to divide into two parts. Can you tell me? Yes, the one is rational numbers and one more is irrational numbers. Yes, so the rational numbers again further divided in. Do you know what are rational numbers? Yes, the numbers which is in the form of p by q. Yes, where p and q are belongs to integers and q not equal to 0. This is the definition of rational numbers. Yes or no? And what are the irrational numbers which is not in the form of p by q? They are called as irrational numbers. Yes. So next you see, for example of irrational number is root 2, root 5. See children, here root 4 is not a irrational number because it is a perfect square number. So children, listen properly. The numbers which are having non-perfect squares numbers or q numbers are called as irrational numbers. Suppose if you consider root 4, it is the square root of 2. Yes, we know the square numbers, no? 2 square is 4, 3 square is 9. So like that, you have to consider, to tell it is irrational, it is, you should know that under the root there is a non-perfect square number or non-perfect q number. Okay, so again this rational numbers are further classified into integers and non-integers. Non-integers in the sense fractions. Okay, fractions. Yes or no? So again these integers are classified into subcategories. That is, do you know negative integers, 0 and the positive integers. Okay, so we all know that whole numbers and natural numbers. Okay, if we further divide this, means we will get the whole numbers. See children, the positive integers only called as a, what we call it as, yes, natural numbers. Yes or no? So what are natural numbers? The numbers which starts from 1 are called natural numbers, or we can tell counting numbers are called as natural numbers, and it is denoted with capital N. See children, for this, if we add 0 to represent the nullity, we again you have to introduce the 0. So along with the positive numbers, if we include 0, then these become a whole numbers. What it becomes? Whole numbers. Okay. So whole numbers are represented by capital W. So they starts from 0. Okay. I think you are having idea about these numbers, but then also I am just recalling the basics of your number system. Okay. And integers are represented with Z. Rational numbers are represented with Q, and irrational numbers are represented with Q dash. In this lesson, our study is only regarding the rational and irrational numbers. Okay. Are you clear with the topic? Yes. So most smallest group is natural numbers. After that, whole numbers. After that, integers and non-integer. Do you know the fractions? What are fractions? Yes, it is also, they are also in the form of P by Q. Yes or no? But what is the difference between rational and fractions number, children? Yes, their numerator, in the rational number, numerator can be negative, but in the fractions, the numerator cannot neither 0, okay, nor negative number. It may be 0, but it not a negative integer. So children, be careful. For the fractions, the numerator will be either numerator can be either 0 or positive integers, okay, but not a negative integer. Here there may be a positive integer, negative integer, 0. Okay. So we come to our chapter. So in the first concept of your real numbers is most important, that is the basic theorem 1.1. What it tells means fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? See children, before going to see the definition, first I'll just tell one example. You first see. Do you know about the prime numbers and composite numbers? Yes. If you don't know means just recall it. If you know means very good. Prime numbers. So what are prime numbers? Did you know? Yes. See children, the numbers which can be divisible by the number 1 and the number itself. What are number itself? Divisible by the numbers which are divisible by 1 and the number itself. If you want, you can write the definitions. What are prime numbers? The numbers which are divisible by 1 and the number itself are called as a prime numbers. For example, if you take 2. So in which tables 2 will come? In 1 tables and 2 tables. So if you take 50, if you take 15, so whether it is a prime number? No. So if you want to, what are the factors of 15? That means 1, 3, 5, yes, 15. See, it along with these two numbers, 2 more extra numbers it is having as a factors. Okay, therefore this will not be a prime number. One more prime number, you give the example is 7. So 1 and 7. See, except in 7, 1 and 7, there 7 comes in other tables? No. Therefore it is also prime number. So what are prime number? Are you clear? The numbers which are divisible by 1 and the number itself are called as a prime numbers. Yes. Clear? So what are composite numbers? Reverse of it. The numbers which are having more than a 2 factors. Suppose if you take 4 also. So what are the factors of 4? 1, 2, 4. Did you know what is the actual meaning of factor and divisor? See children, whenever we are using the term factor means it should divide the number completely. That is, the remainder should be 0. See, divisor means we can expect 0. Okay, we can't expect 0 here. See, suppose if you take 4 by 2. So how will you divide it? 2 by 4. 2 2s are 4. So if you subtract means you will get the remainder as 0. But if I take 5 by 2, what it happens? See, 2, 5. 2 2s are 4. So we left with the remainder 1. Getting my point? So what is factor means it is also divisor, but the condition, one more special condition is there for factor. What it is? It should be a remainder. It should give a remainder as 0. Okay. Be perfect with the every term. Okay. Then only you can easily understand the concept. Getting? So divisor is different. Factor is different. In the divisor there may be a remainder. Okay. But in the factor the number should complete. It should divide the given number should completely divide the given number. Okay. See here. Suppose if I am telling 1, 2 and 4 are the factors of this means, keep it in mind that 1 will completely divide the 4, 2 will completely divide the 4 and 4 is divided by 4. Okay. I can't take 3 as a factor because if you divide 4 by 3 means, so 3 ones are 3, we left with remainder 1. Yes or no? So 3 is not a factor of 4. Okay. Getting my point? See. Now what they are telling, what your fundamental theorem, next you are going to study about your fundamental theorem of arithmetic. Most important topic. They can ask for 1 or 2 1 mark definition directly. Arithmetic. Okay. Before going to understand the definition, first I will make you to understand with the help of example. So see children, if I take any composite number, say for example if I have taken 12, okay, this 12 can be, I can write by using prime factorization of 10. You know what is prime factorization? Factorizing the terms using the prime numbers. Okay. So see, 2 6 are 12. Okay. Next 2 3s are 6. Next 3 1s are 3. Are you observing? I am taking here only the prime numbers. Okay. You can see, you can divide 4 3s are 12. Like that also you can divide. But what I am telling, prime factorization. Whenever we are discussing with the prime factorization, you should keep in mind that the numbers what we are taking are that there should be a primes. Okay. So how can I express 12 as? I can express 12 as 2 into 2 into 3. Isn't it? So 2 2s are 4. 4 3s are 12. So if is there any doubt in your prime factorization, you can cross verify by multiplying your primes. Okay. If you multiply your prime numbers, you should get a given number. Then only your prime factorization is correct. Okay. See children, What the prime factor is? See, this is a composite number and these are the prime numbers. So what the fundamental theorem will tell us means, so every composite number, keep it carefully, observe the listen it, every composite number can be expressed as a product of, we are using here multiplication symbol, what it indicates? Product of prime factors. Okay, prime factors, yes or no? So 12 can be written as 2 into 2 into 3. If you take another number, we can write it in the form of prime factors. Okay, and I can write this as 2 into 2 into 3, or 2 into 3 into 2, or 3 into 2 into 2. Okay, the order is not necessary, but every composite number can be expressed as a product of its prime numbers. So now you see the definition. What it is telling, you see, every composite number can be expressed, okay, as a product of primes. Yes, understood? Every prime number, every composite number can be expressed as a product of its primes, and this factorization is unique apart from the order in which the prime factors occurs. I told no, you can write it as 2 into 2 into 3, you can write it as 2 into 3 into 2, you can write it as 3 into 2 into 2. Okay, clear? Yes. And next is about LCM and HCF. Before going to start the exercise, I will just glance about the HCF and LCM. Okay, do you know the full form of it? HCF means highest common factor. Okay, and LCM is least common multiple. See, just don't behead the concept. Okay, just first try to understand the concept clearly. Suppose if I have already done the prime factorization of 12. If I take one more pair of numbers, if suppose I take 6 and 20. Okay, na, we'll do the first prime factorization of this. So what are the prime factors? If we suppose take 6, you can take 2 or 3. First start with the smaller number only. 2 3s are 6. Next 3 1s are 3. See children, 6 is a composite number. How I have expressed this? 2 into 3. Yes or no? Yes. Next 20. So now we have to do the prime factorization for this. 2 1s are 2, 0 as it is. Next 2 5s are 10. Next 5 is again a prime number. It can't be further, it cannot factorized. Okay, so 5 1s are 5. So 20, how I can express 20? 2 into 2 into 5. Okay, I will write here only. So 2 into 2 into 5. Okay, how can it be written as 2 square into 5? Okay, now be careful children. How I can write HCF? Simple, very easy. Most of the student will get confused to find HCF and LCM, but it is too easy. See children, in both the numbers, first you have to write the prime factors like this by doing this method, and first you have to see the numbers which are in common in both of the composite number. See children, here 2 is common, here is also one pair, so one pair it has. Next 3, here 3 is there. Okay, now but here it is not there, so it is not a common. And 2 it is here, but it is not there, one more pair. And 5 is here, it is not there in the 6 factors. Okay, so what is the common we are having here? 2. Therefore HCF is 2. Okay, and taking the LCM is very important. What to do means, first we have to write down all the factors, all different factors. What are factors? here what are the different factors we are having here? 2, 3 and 5. So first, don't see any powers, nothing. First you write down the numbers, the factors which are different factors. Okay, how many factors they are having, you have to write the factor as it is. After writing the factors, listen, after writing the factors, we have to see their powers. Which are having highest power, we have to mention it. Suppose you see here 2 and 3 we are having. Okay, here we are having 2 square and 5. Okay, and we have written all the factors first. After that we have to see the highest power of the respective number. Okay, see here we are having 2, means it is having power 1, and in this we are having 2 as 2 power 2. So which is biggest, children? This one. 2 square is the highest power. Therefore I will keep the highest powers here. Next you see 3 here. 3 in the next two factors we are not finding 3. Therefore only one number, and that is having, if it is not there on the power, means it is understood that it will be a 1. So 1. And here also 5 we are having. Okay, 5 ones. Okay, and getting, so we have to write all the factors what are there in these two numbers, and we have to search for a highest power. Okay, now we have to multiply. 2 square means 4, 3 5 is a 15. So 15 4s are 60. Yes, so 60 is the LCM of these two numbers. If you want, you can see the definition also in the textbook. They are given. See what is HCF? Product of smallest power of each of the common prime factor in the numbers. See what they are telling. Product of the smallest power. See children, here product of smallest power. If you want to take one more, like 2 into 3 if you take, means, and here 2 square into 5. See, the number should be in the number, and it should be containing smallest number. If you want to understand, means understand this, all are same. Okay, and one more is greatest power of it. This is LCM. You see children, product of the greatest power. Okay, I told now, product of greatest power of each prime factor involved in these numbers. Each means every number you have to take. Here common they are telling. Common means it should be containing in both the numbers. If they give 2 numbers, it should be containing 2 numbers. Otherwise, if they are given 3 numbers, the number should containing in it should be a factor of 3 numbers. Okay, that only you can take. Okay, now they are telling now common factor should be containing in all 3. Okay, and understood? This is all about some basics introduction about this chapter. From next class onwards, we'll start the exercise problems. Okay, if you understand the concepts, please like, share and subscribe my videos. Thank you.